Right. So yesterday we talked about theoretical probability, and it was just the probability that an event would occur. And we did the number of ways to succeed for that event to occur over the total number of outcomes. Today we're going to take that and we're just going to go a little step further, and we're going to find the probability that multiple events will occur. So they're called compound events. So compound event is going to be two or more events. And so I don't know if any of you know anything about betting, but there is a thing that you can bet on that's called a parlay. Have you guys heard of a parlay before? Yeah. So it's like you bet that all of these things are going to happen. So like Steph Curry scores 15 points, and like there's also a football game that day, and Derrick Henry rushes for 50 yards, and all these other things happen. One of those things happening is a pretty high probability, but when you keep adding events, you keep building on events, it makes the probability of all of them occurring smaller and smaller and smaller. Because what you do is you multiply all the probabilities together. So if there's a really high probability, so anyway, you take those probabilities and you multiply them together. The more fractions you multiply together, the smaller and smaller the probabilities get. So there are two types of compound events. One is called an independent event, and what I just talked about with the parlay is typically an independent event. So Steph Curry scoring 15 points doesn't have any effect on what Derrick Henry does in a football game, and that doesn't have any effect on what someone does in a hockey game. So when one event doesn't affect the other event, then it's called an independent event, and all you have to do to find the probability that both of them occur is multiply their probabilities together. So whenever you want to find the probability of more than one event occurring, you are going to multiply. Now, dependent events, one does affect another, and you're still going to multiply, but you have to think about it a little bit more. So we take the probability that the first one occurs, and we multiply the probability that the second one occurs after A occurred. So you're still going to multiply on both of the different types, but you have to think about it a little bit more when they're dependent events. All right, so let's look at number 11. On number 11, a die, which is like a number cube, the singular form of the word dice. A die is rolled 3 times. We want the probability of getting 1 on each roll. So it's the probability of a 1, and then you get another 1, and then you get another 1. So this is a situation where you're going to multiply the probabilities together. And where probabilities can be percentages or decimals or fractions, we're mainly working with fractions on these. So if you roll a die, what is the probability that you get 1? 1 out of 6. So there's 1, 1, and then there's 6 sides. So it's 1/6. All right. And then the next one, it's still 1/6. And then getting a 1 again is still 1/6. All right. And then to find the probability that happens 3 times, you just multiply those together. And you can do that in the calculator if you want to. But that's going to be 1 over 216. You're welcome. All right, let's look at number 12. So a coin is tossed, and then a day of the week is selected. So what you toss on a coin, whether heads or tails, does it affect what day of the week you're going to pick? No. So this is independent. And so we want the probability of getting tails on the coin and then selecting a letter that starts with a T. I'm sorry, selecting a day that starts with a T. So what we're going to do is just multiply those probabilities together. So when you toss a coin, what is the probability of getting tails? 1/2. All right. And then what about selecting a day of the week that starts with a T? 2/7. So there's 2 days, Tuesday and Thursday, that start with a T out of a total of 7 days. All right. Then you can just type that in the calculator and you're going to get 1/7 is the probability that that happens. Both of those things. All right. And then the rest of well, actually 13 through 20, we're going to be drawing crayons out of this bag. And the bag contains 8 red, 14 purple, 6 yellow, and 4 green crayons. On 13 through 16, you're going to select a crayon and you're going to put it back in the bag and then select another one. So does what you select first have any effect on what you select next? It doesn't because you put it back. So you're right. All right. So on this one, we want to select a purple and then I'm going to put and here and then select a yellow. So because this is a compound event, we want the probability of 2 things happening. We are going to multiply the probabilities together. So let's start with purple. How many purple crayons are in the bag? 14. And then to find the totals, this is very similar to marble questions. It's just crayons instead. We'll just add all those numbers together, and that's 32. All right, so then you put that purple crayon back in the bag. What is the probability the next one is yellow? Very good. There's 6 yellow crayons out of a total of 32 crayons. And then you just multiply those together. And you get 21 over 256 is the probability. Okay, you guys try 14 on your own. We want the probability of getting a green and then getting a red. Oh, on a number cube, there's 6 sides. Thank you. All right, so we are going to multiply those probabilities together. So in the bag, there's 4 green out of 32. You put that back in, and then there's 8 red out of 32 crayons. And when you multiply that, you get 1 over 32. Okay. Now 15 is worded kind of in a way that might confuse you. So 2 purples means you're going to get a purple and then get another purple. So you can rewrite it if you want to. If 2 purples makes perfect sense to you, you don't have to rewrite it. but we're still going to multiply probabilities. So we're going to draw a crayon out. We want a purple crayon. There's 14 purple out of a total of 32. And then you're going to put it back in. And then we want another purple. So what do y'all think?
14.
Good. Still 14 out of 32. And then we just multiply that together. And it's 49 over 256. All right. All right. So you guys try 16, please. So probability of a yellow and then another yellow. All right. So that's 9 over 256. Okay, now this next one, we have the same bag of crayons. So 8, 14, 6, and 4. But this time you're going to select one, but then you're not going to put it back in the bag. So this one is a dependent event. So after you select one, there's one less crayon that you're selecting from. All right, so for 17, we want to choose a yellow, keep it out of the bag, and then choose a red. So we are still multiplying probabilities. We just have to think about it a little bit more than on the previous one. All right, so yellow crayons, I know there's 6. And when we first choose, there's 32 total crayons in the bag. But we're going to keep it out. And now we want a red. So how many red are there? Good. There's 8 red. And then now there's a total of 31 crayons. All right, and then when you multiply that, you should get 3 over 62. All right, so I want you guys to try 18. We want to get a purple, and then we want to get a green. Okay. You should get 7 over 124. All right, 19 and 20 are similar but slightly trickier than 17 and 18. So 2 reds means we want to draw a red. And then draw another red. And don't forget, you keep it out. So the first red is going to be 8 out of 32. So keep it out. 7 out of 31. Good. So the second red, there's one less red in the bag and one less total. Right, and then when you type that in, that's going to be 7 over 124. Okay, so you guys try 20 on your own, please. Okay, so for the first screen, there's 4 out of a total of 32. You keep it out. Now there's 3 out of 31, which gives you 3 over 248. Thank you. Okay, we're just going to do a couple more. You guys seem like you're understanding this for you guys. This one is a card question. So if you're not familiar with a deck of cards, you can always keep out that paper or this right here that has all the cards. So this one, we want a card is drawn and then not replaced, so you keep it out, and then another card is drawn. We want the probability of choosing a heart and then choosing a spade. So I know that there's 13 hearts and there's 13 spades originally in a deck of 52 cards. All right, so probability of a heart and a spade is a little harder to draw. And we are going to multiply these probabilities together. So there are, like I said, 13 hearts out of 52. And you keep it out. And then what about the spade?
13 and 52.
Close.
51.
Yes, good. And then if you multiply all that together and reduce, you get 13 over 204. All right, and then the last question. Jack has 4 Snickers bars and 8 Mars bars. He randomly chooses a piece of candy, ate it, and then chose another piece. What is the probability that they're both Snickers? So probability of Snickers and Snickers. Okay, so 4 Snickers out of how many bars? 12. He eats it, and then he wants another candy bar. I think that Jack's going to have diabetes. What about the next one?
3 over 11.
Good job. All right, so that's 1/11 when you simplify it all out. Yes.
Can you go back to 21?
Yes. All right, any other questions? Okay. Okay.
Thank you.
You're welcome. All right, so your assignment today is just to finish that worksheet from yesterday. So hopefully you got 1 through 12 finished. We didn't have a ton of time yesterday, so you might still need to do some of those. And then 13 through 26 today. And there's a little bit of a typo on number 17. It's just a typo. It's fine. Like this and doesn't really need to be here. So we want an even and then an odd.